Hey guys, it's Chris at Highline Guitars, and you're watching another episode of From the Luthier's Workbench. If you like to build or repair guitars, I suggest you click that subscribe button down below, and you'll become part of a community of fellow luthiers. And together, we can take your skills to a whole new level. If you'd like to support my guitar building YouTube channel, visit eguitarplans.com and buy a plan. A link is in the description below. Now on with the video. Since the laminated guitar is now finished, I'm ready to move on to the next project for this channel. However, instead of building another guitar, I've decided I'm going to invite you to follow along as I research, design, and develop a new pickup winder. Now, if you've followed this channel for as long as it's been around, you'll know that I have built a number of pickup winders over the years. In fact, I think the first one I completed about 12 years ago. And each winder that I built after that was an improvement over the previous winder, sort of an evolution of my knowledge and skill when it comes to making the winders as well as using them. And the last winder that I built was what I call winder number 5. And that is a winder which made use of a cam-driven auto-traversing mechanism. So the winder was pretty much fully automated. I could just put a bobbin on the bobbin spinner and feed in some wire, hit the start button, stand back and watch it wind the pickup. As I was making that winder, however, I kept asking myself, what could I do to make it better, to make it faster, more efficient, less expensive, that sort of thing. And I kept going back to this idea of applying CNC technology to pickup winding. I knew that there were others who've gone down that path before, and I just kept wondering, maybe that's something I should explore myself for the winder. Well, as I started to do a little bit of research, I quickly began to realize applying CNC technology to pickup winding is a lot more complicated than you might think. And I quickly began to realize that I might be biting off more than I can chew. So I ended up deciding to back burner that whole idea, and I continued on and finished with winder number 5. And that's the same winder which I offer an assembly manual for on my eGuitar Plans website. Now, I've been using that winder for the past year or so, and it's worked out great. It's a lot of fun to use. However, I kept thinking about, what if I applied CNC technology to a winder? Is it possible? Could I do it? So over the last year, I've kind of been doing a little bit of research and thinking about how I might be able to do this. And I think I may have come up with an approach, and I've been testing some ideas. So what I've decided to do is I'm going to video this process and share with you the experiences I'm having as I design and build this winder. And then hopefully once it's done, I'll have a machine that's actually usable, and then I could possibly offer an assembly manual for that machine. However, I will say it is more complicated than the winder number 5. Winder number 5 is pretty simple to use. The only disadvantage or the only challenge to using that winder is getting the cam shapes just right. And the one that I included with the manual seems to work well, but there are a lot of little variables in the whole design. But with this new CNC technology, I think I can make it even easier to use, but it may be more complicated. I don't know. We'll just have to see. So let me bring you in a little closer and I'll show you where things stand at the moment. Now let me explain what I've got going on here, because this is going to seem kind of confusing. This is a test bed, and here is where I am testing this CNC concept that I have for controlling a pickup winder. And I'm using my old CNC winder I shouldn't say old, it's only a year old, CNC winder number 5. And the only component from this winder that I'm actually using for the test is the 12-volt DC motor that turns the plate which you mount a bobbin to when you wind a coil. And over here I have a stepper motor, and this is the stepper motor that I will use to control the traverse of the wire as it's winding onto the bobbin. It's not actually this stepper motor. This is a NEMA 23. The one that I'm going to use to control the traverse is a NEMA 17. But what I'm going to be doing is I'm going to use a very small CNC Z-axis slide. It's a prefabricated, self-contained component, and I'm just waiting for that to arrive. It's been shipped from China and probably going to take a while to get here. I'm actually waiting for several components. I'm also waiting for the counter. So until all that stuff arrives, what I can do is test the concept I have, primarily how I write the G code to control all this, because there are some challenges here. First of all, with the traverse, when I made winder number 5, I knew from experience that when you traverse wire, especially if you're using an auto-traversing mechanism, how the wire is traversed across the width of the bobbin can affect how the coil is going to be shaped in the end. And what I have found is logic would dictate that you would traverse the wire in a consistent manner back and forth across the width of the bobbin. However, what tends to happen is when the traverse reaches the furthest extent of its travel, it has to stop and reverse itself. And then it passes back over the center of the bobbin until it reaches the other side. Then it has to stop and reverse itself again. That act of stopping and reversing causes a very slight delay, which can cause wire, excessive wire, to build up at the edges. So you end up with a bobbin or a coil that has a flared shape to it. There's more wire at the outside edges than there is in the center. As a result, what we try to do is compensate by slowing down the traverse at the center of the bobbin. And if you're not careful, that can cause excessive wire to build up at the center, so you end up with a bulge in the coil. Now, these issues are really more cosmetic than they are anything else, but they can cause a problem when you're trying to wind the bobbin, in that they won't allow you to get as much wire on the bobbin as you would like to. So it can cause problems. What we therefore try to do is to control the speed of the traverse so that we can lay the wire down in a manner which will allow for a coil shape, which is going to give us the opportunity to put as much wire on the coil as we can, so that it's not spilling over the sides. So with the manual auto-traversing mechanism, the one that has a cam that drives the traverse back and forth, it all comes down to the shape of the cam. And it took a long time for me to get the right shape for this cam in order to distribute the wire in a consistent manner across the width of the bobbin. With a CNC controlled traverse, it all comes down to how the G code is written. And that was my first challenge. But what I've kind of come up with is a way to write the G code so that it will control the direction and speed of the traverse during the course of the traverse. And that's what I'm testing here. Now, this whole setup consists of the controller itself is an Arduino Uno, which is flashed with Gerbil 1.1, which is the CNC software language that I use. And then connected to that Arduino is a Synthetos G-Shield version 5, and that's what I'm using to control the stepper motor as well as this DC motor. Now, you're also seeing a 24-volt power supply here. This whole unit here was actually salvaged from my old Inventables X-Carve. I'm using that same technology. And at the moment, the Arduino and the G-Shield are bolted to the top of a 24-volt power supply. However, I'm not actually using this power supply. It's disconnected. It's not even plugged in. Instead, I'm using just a 12-volt, 5-amp power supply, which is plenty to drive both the motor, the DC motor, and the stepper motor. So I won't be using this at all, and later on I'll be removing these components. But for now, I wanted to be able to quickly set this up and test it. Because the other challenge I had is I'm going to be using the G-code and CNC technology to drive a 12-volt DC motor. It's not a stepper motor. This is just a regular brushed gear motor. And the problem is you can't drive a DC 12-volt motor from one of the stepper drivers that are built into the G-Shield. It doesn't work. These drivers only work with stepper motors like this one. This was easy to control. I just simply wired it into the x-axis, and that's what I'm always going to be using to control the traverse. But to control the DC 12-volt motor, I had to find a separate external driver that I could wire into this shield. So what I end up doing, and this was another theory I wanted to test, was I'm treating this 12-volt DC motor like it's a spindle connected to a CNC shield. So what I have is a connection from this shield to a separate DC motor driver, and this one allows me to connect the enable and the direction pins from the shield directly to the driver. As a result, I'm able to control both the direction that this motor will turn as well as the speed. And so what I have to do now is I have to send the G-code that I've written from my laptop to the Arduino, which will then process it and send the appropriate signals out of the G-Shield to the stepper motor and to the DC 12-volt motor. And I want to see if this idea that I have is actually going to work. So let's give it a shot. As I conduct this test, there's two things that I want you to pay attention to. One is this is the plate where the bobbin is mounted to as I wind the coil. So watch what this is going to be doing, and then watch what this stepper motor is doing. I have a piece of tape on the shaft so you can see what direction it's turning. But the way I've written this code is this plate will start to spin very slowly, and then over the course of about 12 seconds it will gradually increase in speed until it reaches its maximum RPM, which is 1200 RPM. And once it reaches that, it will stay there through the course of its operation. The traversing stepper motor is going to be turning one direction and then turning another direction. And what I've also done is I've written the code so that it will speed up at each end of its range before switching direction. I've also found a way to write the code so that it will do its thing in one speed, and then it will switch to a faster speed, double its original speed. And I can vary that throughout the course of a winding operation so as to achieve a scatter wound pattern. So watch this motor and then watch this one. And this is just a very short code file. It's not one that would last the full 4 to 5 minutes it would take to wind a bobbin. I just wanted to get it started. So what I'm going to do is I'm using a program called Universal G-Code Sender on my laptop. And what I'll do is I will navigate out to the file that I've created. I'm calling it Winder Test. I'll click Open. And then all I have to do is hit Send, and the whole operation, it'll send the G-code through the USB cable to the Arduino, And then the Gerbil, which is installed on the Arduino, will process that G code and send the appropriate signals either to the DC gear motor or the little NEMA 23 stepper motor. So let's see what's going to happen. Now this file should last about 20 seconds, but as you can see, the motor is spinning up to full speed and the stepper is going back and forth and occasionally speeding up. And then slowing down again. And that's it. It's just a short file, so I think it's pretty clear. The G code is doing exactly what I was hoping it would do, so I'm really encouraged by this. Of course, all of this could change when I put a load on the motors. I don't think it's going to matter much for the DC 12 volt motor because the load is so minimal. But we'll have to see what happens when I install and construct the traversing mechanism. So that may change things a little bit, but I'm pretty confident it's going to work just fine. So that's where things stand at the moment. And I have to say I'm pretty encouraged with how this test went. The G code that I wrote is doing exactly what I was hoping it would do for both the stepper motor and the DC motor. So really, I think what I need to do next is to begin assembling the actual winder. Of course, I can't do this until all the parts that I've ordered have come in. And at the moment, I'm still waiting for the Z-axis slide that I mentioned earlier, which will constitute the auto-traversing mechanism. I'm waiting for the counter, which is a really cool counter, and I'll explain that in a future episode. And the sensor for the counter. So once all that stuff comes in, I can actually start to put this together. I don't think assembly will take that long, but once I get it together, then I can really start to test it with this concept I have for the G code, and we'll see if the idea that I just tested will actually work in a real world winding scenario. So stay tuned for that. I'm not sure how many episodes this series is going to require. What I will do, however, is I'll create a playlist, and I'll put a link to that playlist in the description below as well as at the end of this video. That way, if you're following along and are really interested in how this project progresses and you're afraid you've missed an episode, you can just click the playlist and go back and see what I've already posted up. So with that being said, if you have any comments or questions, be sure to put them down below. However, at this stage, I have to be kind of careful about what information I will reveal when answering questions, because I don't want to get into too much detail yet until I'm certain that this machine is going to work. Then I'll put the information out there. And my plan is to eventually, if all this works out, is to create an assembly manual like I did for winder number 5, and I will make that available on my eGuitar Plans website. So, but again, it's just going to depend on whether or not this whole machine is going to work in the manner that I hope that it will work. Also, I'm a bit concerned that this concept is going to be really complicated for some folks to use. So, you know, I'll make sure that I try to explain that in future episodes so that you can decide whether you want to go with a CNC winder or a more of a manual auto-traversing winder like I had with winder number 5. At any rate, if you don't subscribe to my Highland Guitars YouTube channel, please hit that subscribe button, especially if you're interested in building guitars and making pickup winders and that sort of thing. And as always, if you want to help support my channel, head over to eGuitar Plans, purchase a plan. Even if you don't plan to build a guitar or the tools, if you like this channel and want to help support what I'm doing, that's a way to do it and to get something in return. So until the next episode, take care, stay safe, and I will see you soon.